Okay, welcome to another Comp 1 Programming Exam Solution tutorial, and this is going to be one of the last ones. This time tomorrow it will be all over for another year. So all the best if you're sitting the exam tomorrow. If you're not sitting the exam tomorrow, I'm not quite sure why you're watching these videos. Yesterday I thought up about having a changing key for the CaesarCipher, and by that I mean one that isn't fixed. So the aim of this is to simply spelled cipher wrong there. The aim of this is to tell I'm tired, to just have an incrementing key. So basically for the first character the key will be 0, for the second character it will be shifted by 1, third character will be shifted by 2, fourth character will be shifted by 3, you get the idea. Why am I doing it in that way? It's the absolute simplest to code. There's very little effort at all in order to do this. Obviously if there is a different spec you're going to have to add or subtract or do whatever, think of the maths, but let's just see how we do it for this very simple case. So the steps we're going to take is obviously new menu item, new case, blah blah blah, and what we're going to do is just copy and paste the use CaesarCipher function, but we're then going to remove the amount to shift, and then we'll increment the amount to shift as a local variable within the function. So I've actually already coded it. In fact, I want to delete it and you can see what I've done. So let's delete that to keep it nice and simple. So basically I've created my new function called use CaesarCipher floating key, and you'll notice that I'm just passing in the original text. So basically what I've done is I've just got rid of this amount shift. I then copy and paste this across, Control C, Control V. Obviously I need to change this to floating key so that it matches the name of the function, because that's what's going to return. I've now got a problem here because amount shift doesn't have scope within this function, so I need to declare it. And amount to shift as integer, and I'll initialize it as well, I think. No, I don't need to do that actually. And now all I need to do is simply control amount shift, and this is actually the tricky bit. Because I want it to be different for each character, I'm going to place it within the loop that is basically shifting through the characters. So hopefully you remember how this piece of code works. This for loop here basically goes through each and every character in the original plain text, and it normally shifts it by a set amount by calling this function apply shift to ASCII code for character. So at the moment this gets a fixed amount in this function. What we're going to do is get it so that amount shift changes for each one. So we're going to relate it to count. So amount shift, and we better have that equaling to count, will be the easiest thing to do. So it goes 0, 1, 2. The killer is if we do this, if there is more than 26 characters, we will end up shifting more than 26 amounts. Now as it happens, it may be that this accounts for that, but we don't know. So what we're going to do is we're going to add in a mod 26 so that now amount shift will cycle through 0 to 26, and on the 27th character it'll be 1 again. You get the idea. So the 26th character will be 0, 27th character to be 1, 28th character will be 2, and yeah, that's it. Now up here I've already added in a little extra case statement just because you don't need to see me add that in, and I've got my plain text equaling and then the call of the function, and rather than passing in plain text I've just passed in a literal. I assume you know you can do this. You don't need to have variables here. This is a literal parameter where I've literally put in the string and I've whacked in 30, well I think it's 30 A's. And hopefully you can work out why that's a good test for this, because hopefully this should return when we display the plain text afterwards, or the ciphertext I should say here. Yeah, that should be display ciphertext really, but it doesn't really matter, it's the same thing. That it should return A, B, C, D if you get the idea. So let's see if it does. Let's just quickly return it. Go to R, and you can see that we've got A through to Z, followed by AB, so we can see that's working. You know, obviously I would normally work in the same way that all the others and stick in plain text there, and it really is annoying me that I've accidentally called that display plain text. That really should be ciphertext because we're encrypting, and this should be display ciphertext with ciphertext there. It's one of the things that annoyed me about their code actually, that display plain text and display ciphertext are absolutely identical functions, so really we could have just had display text there. Okay, so changing amount to shift within a new function effectively gives us a changing key, a little bit like the rotating wheel of the Enigma machine. Those of you that have looked into ciphers a bit more, I hope you have found that useful. I will have a little go at it for the steganography, where I'll stick in some upper and lower bounds. Obviously this could have upper and lower bounds, but you're just going to have to pass. You just have to pass them in and work with them here. But we'll look at the upper and lower bounds for steganography, and I'll also perhaps have a little try at the using an irrational number, so you can see that as well.